right, guys. Today, I would just like to do a little bit more with multiplying and dividing, okay? Namely, incorporating some distributing. So remember, distributing is just multiplying more than one time, okay? So again, just remember, so here, do you see I have one thing in front? So that one thing though, since it's front of parentheses, has to multiply everything inside the parentheses. So just recall the way we multiply with radicals is we multiply insides with insides and outsides with outsides. So here I have to multiply a rad 5 times a rad 2. Since they're both in rads, I'm allowed to multiply them to make rad 10. Okay, then I bring down my plus and I do the same thing here. They're both in rads. I'm going to multiply them and get rad 50. Now again, remember with multiplication, you multiply first and then check to see if you can simplify. There is nothing I can do with rad 10, so I'm going to leave that alone. However, rad 50 can be broken down into 25 times 2. Recall that 25 is a perfect square, so that's going to simplify to 5 rad 2. I can't do anything else than that. Since I can't simplify the rad 10, I'm just going to bring it down, and that is my final answer. Okay, so you're going to multiply, and in this case, more than one time, and then you are just going to simplify if you can. So here, a rad times a rad is going to be 3 times 3, still in a rad, 9. Here I have another rad times a rad, 3 times 27 is 81. Again, don't stop there until you see if you can simplify. We can simplify because rad 9 is a perfect square. It's just 3. Rad 81 is a perfect square, it's just 9. Since these two end up being whole numbers, I can actually add them to get a final answer of 12, okay? So here, do we see we only have a plain old number in front? That's fine. So remember, we're still there's only 2 terms inside these parentheses, right? Because there's only one plus sign. So remember, we're gonna multiply outside numbers with outside numbers. So here, 2 is technically not in a radical, so it can only multiply numbers not in a radical. So I could do 2 times 3 is 6. And do you see, since 2 doesn't have a radical on it, there's nothing else to multiply this rad 2, so I'm just going to bring it down as rad 2. That's it. Now my second multiplication is just 2 times 5. Since they're both whole numbers with no radicals, I can multiply them and get 10. For a split second, I'm going to look and see if there's anything I can do with this rad. Since it's a rad 2, nothing more can be done. We just distribute and go. Okay? In number 4, you'll notice I'm adding just more stuff as we go along. So number 4, I'm still only gonna multiply twice, but do you see now I have an outside and an outside, I have an inside and an inside. So when we do, we're gonna pretend this isn't here. Remember, we multiply outside numbers and get 6, inside numbers and we get 14, but it's still in a rad. We bring down this plus, we ignore this one. Outside times outside is 3 times 5. Which is 15. Inside times inside is 2 times 3, which is rad 6. We're going to check to see if we can break down 14 anymore, which we cannot. We're going to check to see if we can break down 6 anymore. We cannot. So we're going to call it a day and box it up. Okay? So same thing here. Again, distribute twice. Pretend this one isn't here. Outsides with outsides is 16. Insides with insides is rad 24. Bring down, in this case, the minus. Forget this is here. Outsides with outsides is 24. Insides with insides is rad 36. Okay? So then we're going to just stop and look, and now we do have some simplifying to do. Okay? So I'm going to bring down this 16. Rad 24 can be broken down into the biggest perfect square that goes into 24 is 4. Okay, so remember the perfect square, we're going to simplify to be 2. And since I have 2 outside numbers that aren't in radicals, I am allowed to multiply these to get 32 rad 6. Okay, so a lot of work just to get that down here. Now, this is 24 times, now rad 36 can be simplified, but it's perfect. Remember, if it's perfect, it's just gonna be a number. So this is just 24 times 6, okay, which ends up being 144. So I'm just gonna bring it all the way down here since there's nothing more I can do with it because it's not in a radical anymore. So that's my final answer. So again, if you distribute to 2 terms, you're typically gonna end up with 2 terms as your answer, unless it's like number 2, where they both end up being whole numbers and you can combine them. Okay, so it's just a matter of what you get here. Okay, so one more. We're gonna distribute here. Okay, so pretend that's not there. Outsides with outsides is 15. Insides with insides is rad 40. Bring down your plus. Forget this is not here. Outsides with outsides is 10. Insides with insides is rad 50, right? So again, stop and look, see what you got. So here do we see we have rad 40 here. That can be broken down into 4 and 10. Square root of 4 is 2. So this fully simplifies to 30 rad 10. Okay? Over here, we're going to bring down our plus. The 10 comes down. Now 50 breaks down into 25 and 2. 10, the square root of 25 is just 5. 10 times 5 is 50. I get 50 rad 2. Remember, that's the best I'm going to be able to do because we can't actually add these because they don't have the same number under the radical. So pretty much on the distribution ones, like after you simplify, you're done. There's not really combining like terms after. Okay? Now, the distribution can get a little more complicated where you have more distributions to do. Now, do you see this one? Do you see because I have 2 things inside of parentheses times 2 things inside of the parentheses, I'm gonna have to double distribute, which means I'm gonna have to do 4 multiplications here, right? So we're gonna start with the 3 and we're gonna send the 3 into both terms. So let's forget about this right here. So the first thing I have to do is 3 times 5. I'm allowed to multiply those because they're both out of radicals. So 3 times 5 is 15. But the next thing I have to multiply is 3 times negative rad 2. So I'm gonna get a negative. But do you see the 3 is not in a radical and the 2 is inside a radical? I can't multiply that 3 and a 2. It's like when you have to multiply 3 times x, you just get 3x. So 3 times rad 2 is just 3 rad 2. You can't do anything with that, okay? Next thing I'm gonna do is distribute the rad 2 twice. So same thing, I have a rad 2 times a plain old 5. Can't multiply those because one's in, one's out. So we're just gonna bring it down as 5 rad 2, okay? Then the last thing I'm gonna do is this rad 2 times this negative rad 2. Okay, so a positive times a negative is negative. 2 times 2, I am allowed to multiply them because they're both in the radical. So I get radical 4, okay? So now we're gonna stop and look at our radicals and see if we can simplify them. Do you see, I can't do anything with a rad 2, but I can break down a rad 4 to just be a plain old 2, okay? The square root of 4 is 2, okay? So before I can actually go on my way, you will notice I do have some like terms that can be combined. Do you see I have a whole number and a whole number here, right? A number without a rad and a number without a rad, okay? So any number without a rad can be combined with any number out of a rad. So 15 plus negative 2 is 13. Do you see this has a rad 2, this has a rad 2? So we learned like 2 weeks ago, if they have the same rad, you can add them, but you only add the numbers in front. So negative 3 plus 5 is positive 2, so it's gonna be a positive 2 rad 2. Now that is it, guys. That's all you're gonna be able to do. It's very tempting to want to add this 13 and this 2, but you're not allowed because this 2 is attached to a radical 2. You would only be able to add the 13 and the 2 if this were also a 13 radical 2, okay? All right, so we're gonna do the same thing with the next ones, right? We're gonna just, remember, 2 sets of multiplications. 5 times 2 allowed to multiply is 10. But 5 times rad 2, not allowed to multiply. So we just make it 5 rad 2. Rad 3 times 2, can't multiply. So we're just gonna write it as 2 rad 3. Here, rad 3 times rad 2, I'm allowed to multiply. It's rad 6. Remember, a rad times a rad is another rad. Okay? Now with this one, if we look, do we see rad 6 I can't break down. Rad 3 I can't break down. Rad 2 I can't break down. So I don't have to simplify any radicals. But then when I look, do you see there's absolutely no like terms in this problem? None of the rads are the same numbers. And then we don't have any other plain old number to combine with the 10. So for this one, that's your final answer. So remember, we did mention last week that squaring gets looped into the multiplication because remember, 3 plus rad 5 squared means 3 plus rad 5 times 3 plus rad 5. So there's your 4 multiplications, right? So we're going to do 3 times 3, allowed to multiply, and we get 9. 3 times rad 5, can't multiply. So I just write 3 rad 5, okay? Then we're going to do the second set of multiplications. Again, 3 times rad 5, I cannot multiply, okay? Rad 5 times rad 5, I can multiply, and I get rad 25, right? So then we're going to look at our rads. Rad 5 can't do. Rad 5 can't do, at least simplify. Rad 25, I can simplify. That's 5, okay? So now I'm looking at what I've got left. So everything is simplified, but I haven't combined like terms. Number with number, I'm allowed to combine, and I get 14. Radical with radical, I'm allowed to combine, and I get 3 plus 3 is 6, and I bring down the rad 5. Technically, it doesn't matter if you combine the rads first and then brought down the 14. These two can be in any order, okay? So that's as complicated as the multiplication gets with the with the double distributing. Okay, the last thing I want to do is talk about distributing with division. I know that sounds strange, okay, but we have done this a little bit before, distributing with division, okay? So when you think of this as because this whole, do you see this rad 2 is technically because of the big fraction bar under each of these? What this really means is the rad 6 is being divided by the rad 2, and the rad 10 is being divided by the rad 2. So if you want to split it into 2 division problems, go ahead. Now remember, the rules for divisions are the same as multiplication. Rad can divide into a rad, and you get rad 3. Here, rad can divide into a rad, and you get rad 5. The best part about this is I can't break down rad 3. I can't break down rad 5. Awesome. I'm done. Okay? All right, so this one again, if I want to break it up into 2 division problems, I could put the 5 over the first one, bring down the minus, and put the 5 over the second one. So here do we see now we're only dividing by a whole number, so that can only divide into other whole numbers that are outside the radicals. So I'm allowed to divide this 5 into that 10 only, not that 5 because that one's in a rad. So 5 into 10 is 2, so I'm just going to bring down that rad 5 that I didn't do anything with. Then I'm going to bring down the minus. Same thing here. This 5 can divide in with that 5. So remember, 5 divided by 5 is 1. You could either write 1 rad 3, because you're just going to have to bring down the rad 3, or if you want, you could leave out the 1 altogether. Okay? So again, it's not a bad idea to just take each of the top numbers, split them up, and put them over whatever you're dividing by. Makes it a little bit easier. So now here we have a little bit of both. We have outsides and outsides, okay? So I'm allowed to divide this 6 and this 2 to get 3. Insides with insides, I'm allowed to divide 18 by that rad 3 to get, but again, still in a rad, 6, okay? Bring down your plus. Outsides with outsides divides to be 4. Insides with insides divides to be rad 5. Again, do a quick check to see if you can simplify the rads any further. There's nothing I can do with a rad 5, and there's nothing I can do with a rad 6, so I am done. Okay? So this last one, again, not a bad idea. Write the 2 rad 5 under each of these terms. Okay, and then divide. Outsides with outsides, you get 8. Insides with insides, you get rad 4. Now here, outsides with outsides, you get 1. Insides with insides, you also get 1. So you don't have to write 1 times 1, but just keep in mind, even if you see, oh, these are going to completely cancel each other out. Remember, when things cancel each other out in division, you get the number 1. Okay, so nothing more I could do with that, but what you will notice is the square root of 4 is perfect. The square root of 4 is 2. So you're allowed to multiply these because now they're not, neither number is a radical. So I get 16 minus 1, which means I can go one step further. Final answer, 15. Okay? So that's a way to kind of bump up multiplication and division a little bit more by doing some distributing with it. All it is, it just makes it just a little more annoying because you have to multiply or divide more than once in a problem. Okay? But that's it for multiplication and division. Nothing more beyond that.